Welcome back, everybody. So this is a video going over section 1, 2, solving multi-step equations. Day 2. Now, what did we do yesterday? Yesterday was solving two-step equations, right? I want to do my addition and subtraction, then do my multiplication and division, right? Do my addition and subtraction, then my multiplication and my division. With one exception, we were talking about some problems where we had to do the distributive property and then do my two-step equation. So what we're going to look at today is more, okay, what happens when we increase the number of steps? What happens when we have to do some simplification and not just the distributive property? Now, remember that to solve a multi-step equation, we simplify each side of the equation. That's going to be extremely more important today. You must simplify the equation before you start to solve. Before you start to move things across the equal sign, you must simplify the equation. Remember that you use reverse order of operations or inverse order of operations when solving multi-step equations, using reverse order of operations. That's what we're looking at, right? You start with your addition and subtraction, then a multiplication division, then your exponents or parentheses if you need to, okay? Now, this question I could have given to you yesterday. This question I definitely could have given to you yesterday. Solve 2.5x minus 13 is equal to 2. What do I do first? Oh, shoot. Is it Noah? Noah.
You add 13.
Add 13. I add 13 to both sides. So that means we get 2.5x is equal to 15. And then what's my next step? What do I do next? Yeah?
Divide by 2.5.
Divide both sides by 2.5. Again, show the work vertically, especially, I was just checking that book work. For some of you guys who weren't showing a lot of work, I get it. They were one-step problems. It's not that bad. These on tonight's homework, okay, if you don't have 4 or 5 lines of work, then it's not acceptable. Okay, you need to show the work. So now we have 15 divided by 2.5. 15 divided by 2.5. That gets me 6. X is 6. Can I still check my answer? Yeah, plug it in. 2.5 times 6 minus 13. 2.5 times 6 is 15. Minus 13 is 2. All right. Now, let's increase the difficulty a little bit. Remember that I say simplify before you start to solve. What can I simplify here? What can I do? Sid?
You have to subtract the two like terms.
Good. I've got to combine the like terms. I've got to say 9x minus 6x. Before I even look to try to solve with that negative 12 on the other side, I have to simplify down. I have to take 9x minus 6x. So we bring down the negative 12, and again, bring down everything you don't use to the next line. 9x minus 6x is 3x. 9 minus 6 is 3. And now this becomes a problem that we had yesterday. See, we're only adding in one little step. Combine like terms, now, two-step problem. Subtract the 15 from both sides. That gets us a negative 27. And now we can do our division. Now we divide by 3 to get negative 9. Now, can I still check my answer the same way that I had? Yes. Even if there's 2x values, you can still check your answer. Let's look at it. Negative 12 is equal to 9 times x, which is negative 9, minus 6 times x, which is negative 9. We just plug in negative 9 in both spots. That's all you do. You take negative 9 and you plug it in both places. Okay, now, let's continue on. We got negative 12. And now this is, and you know what? Let's see. Let's put that whole right side of my calculator. 9 times negative 9 minus 6 times negative 9 plus 15. If this comes out to be negative 12, we know we've got the right answer. Yep. This does check out. This is negative 12, so I can go back and say definitively that negative 9 is my correct answer. Okay. Questions about that? Okay, let's do another one. Same type of thing here. I want to combine like terms and then solve. So let's do it. What is 5f plus 4f? 9f. 5f plus 4f is 9f. Minus 8 is equal to 19. Great. Another two-step problem. I add 8 to both sides. I get 9f is equal to 27. And then I divide by 9 to get f is equal to 3. Questions about that? All right, so now we've done yesterday we did some distributive property and then solve. Today we're doing some combining like terms and then solve. So let's put those together. Let's do some distributive property and combining like terms to solve. So do this one with me here. What's the first thing that I need to do?
Distribute the 2 to the 1 and the negative x.
Good. So I'm going to distribute the 2 in. I take 2 in here and here. So this gets me a 2 minus 2x plus 3 is equal to negative 8. 2 minus 2x plus 3 is equal to negative 8. And now I can combine like terms. You see it? What two terms am I going to combine? What two terms?
The 3 and the 2.
The 3 and the 2. Good. Now, I'd like everybody to look up here, please, because I want to show you a very common mistake that I really don't want you to do. Everybody, eyes up here. I have students all the time do this. I put it in red because it's wrong. Well, remember that I could have put this dotted line here, this dotted line there, and I know I got to do whatever I do to one side, I got to do to the other side. Does that make sense that wait a sec, I should put a negative 3 over here if I truly wanted this equation to balance. This equation is unbalanced. I subtracted a total of 6 on this side. It didn't subtract anything to the right side. So what I'm saying here is you don't do inverse operations when you're combining like terms. That's a very common mistake. You guys get too caught up in doing inverse operations, and then you accidentally do them when you don't need to. All I'm doing here is combining like terms. I haven't even started to solve yet. 2 plus 3 is 5. Bring down the minus 2x is negative 8. 2 plus 3 is 5. So combine like terms, and when you combine like terms, you don't do inverse operations. You just do the operation that's there. Now, can somebody tell me what my next step is? What do I do next? Tommy.
Subtract 5.
Subtract 5. Subtract 5. Be careful. I'm not going to add 5. Even though I see a minus sign, that minus sign is connected to the 2, not the 5. So that gets me, I bring down the negative 2x is equal to negative 13, and now I can divide by negative 2. So x is 6.5. We all right? Yeah.
So could you answer that 6 and then put a fraction?
6 and 1/2, that's fine. Yeah. Notice that if I had given you decimals, give me back decimals, but this is all just whole numbers, right? So I can do whatever you want. You can do fractions, you can do decimals, doesn't matter. As long as it's equivalent. Okay, let's take a look at the next one here. Example B. We got 4 quantity n minus 6 minus 1 is equal to 31. Okay, what's my first step here? What's my first step here? It's Brianna, right? Brianna.
Distribute.
Good. I distribute the 4 in. So that's going to give me 4n, and then 6 times 4 is 24, minus 1. Now, be careful. Be careful. I keep having people tell me that this is going to be 23. It's not 23, folks. It's negative 24 minus 1. What does that give me?
25.
Yeah, minus 25. Minus 25 is equal to 31. Okay, it's a negative 24 minus 1, which gets me negative 25, not 23. Then I add the 25 to both sides. And that gets me 4n is equal to 56. And then we divide by 4. Let's see what that is. 56 divided by 4 Gets me 14. You see how many lines of work we have? Nothing less than that would be acceptable, okay? I need to see each step. Okay? I need to see each step. Okay, let's take a look here. We're on the back, top to back. So let's keep it going. More simplification and then solve. Let's distribute in here with the 3. This gets us a 3x plus 3 plus 6 is negative 9. Don't start solving yet. The temptation is to start moving things across the equal sign. Don't do it. What do I do next?
3 plus 6.
Good. So I get 3 plus 6 is 9. It's tempting to say the other side is going to be 0 now. It's not going to be 0. Subtract the 9. 3x is negative 18. Then we divide by 3. X is negative 6. Remember that I can still check my answer if I really wanted to. If I would like to, I could go back in and plug negative 6 in. If I was second guessing myself at all. 3 times negative 6 plus 1 plus 6, is that negative 9? Let's go in our calculators and check. I've got 3 parenthesis negative 6 plus 1 and parenthesis plus 6. Negative 9. It checks out. I know definitively that negative 6 is the correct answer. Questions? Okay. Let's keep it moving. Guys, didn't we do this on our last quiz? I mean, if I just hide this side, I mean, how many times did we do a problem like that? We've done that a million times already this year, right? Several problems where we've got a double distributed property. So all I'm doing now is saying, okay, if I've got that 14, on the other side, all I'm going to do is do the double distributive property, simplify, and then in the end solve. Okay. So let's do it. Distribute in here and here. 15 minus 5x. Here and here. 6 minus 2x. Now we combine like terms, just like we had before. I've got the 15 and the plus 6 to get us a 21. And then I've got the negative 5x and the negative 2x. Negative 5 minus 2 is a minus 7x. And now we solve. You guys see why it was so important to learn those double distributive property problems? Because we're going to use things later on. You're going to find that all year. We're doing things now that you will use in chapters 4 and 5. We're doing things now that we will use later on in the year. So please, 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 if you don't understand something or you do something on the quiz and you still don't understand why you missed the problem, you still don't understand how to do them, you need to get help. Okay? All right, let's keep it going. What would I do to solve this? Brianna? Subtract 21 from both sides. Good. I have a negative 7x is equal to, okay, look at that, negative 7. We divide by negative 7. X is 1. Questions about that one? Let's do E. Oh, sorry. Nope, I'm right. Let's do E. Now, what's tricky about this one? It's that negative, right? It's a negative coming in. So let's bring in that negative. And that's going to give me 13 is equal to negative y, and then a plus 4 plus 3y. Now when I combine like terms, I'm going to get 13 is equal to 2y plus 4. 2y plus 4. Negative 1 plus 3y. Because, and again, you can treat that like a negative 1y. If you want to put a number out there, you totally can. You subtract the 4 from both sides. That gives us a 9 is equal to 2y. And then I divide by 2, 4.5 is y. Let's take a look at this one. What's your first instinct? What's your first instinct?
To minus 325.
Aha, good. Because a lot of people, anybody else think about something else first? How many of you guys were like, oh, I do the distributive property? Yeah, that's probably what I would have done. But then I realized, oh, wait, what is 5 minus 3? Can I just do that? Can I combine those? Oh, yeah, 5 minus 3 is just 2. Done. So we have 2x and then a 2. Minus 3x is 5. So 2x times 2 is 4x. Minus 3x is 5. Well, what is 4x minus 3x? 1x. Do I need to divide by 1 over to the other side? No. I don't need to do that. I'm just going to make that part of my box. There we go. Remember, 1x is just x. I mistakenly left off an example from the guided notes, so we do have one more thing to do. Got 3 minutes. Got it. All right, the last thing that we're going to talk about is translating words to math. Translating words to math. That's difference means subtraction. Sum means to add. Quotient means to divide. Product means to multiply. All those context clues that talk about what operation to use. That's what we're going to be working with here. So if I've got the difference means to what? Subtract. So I can put a big subtraction sign in there. Okay, the difference of, here's what I'm going to subtract. 4 times a number. How do I represent 4 times a number? 4x. And 4, the difference of 4 times a number and 4 equals 37. Can we solve that? Yeah. I'm going to bypass that real quick because we're running out of time. I believe we can solve that, but I just want to show you one more example of just creating the equation because I believe that that's the more difficult part about these. 14 plus the quotient of a number in 4 is -5. Okay, so we got 14 plus the quotient of a number in 4. How do I represent the quotient of a number in 4? Lombardi?
4x.
The quotient. That's product. The quotient. Brianna? Divided by. So I've got the quotient of a number and 4. X divided by 4 is -5. And then we would subtract the 14 and multiply by 4 over the other side. I know we had to buzz through those. Sorry about that. Let me stop the video real quick. Just as a reminder,